Suppose we plan to produce 14 boats in 6 months. Demand for each month is given in the following table, and no shortage is permitted. The production capacity for production in each month is 4 per month, and we can keep only a maximum of 3 boats at the storage for each month. At the beginning of each month, if there are some boats left from the previous months, we have to pay an inventory fee of $1 for every boat left. Also, in case we intend to produce any unit of production, there is a setup cost of $4. The cost of production is $10 for each boat, and this cost is fixed. Therefore, we set aside the total cost of production of 14 boats. 10 times 14 equals 140, to keep the problem simpler. We assume there is no boat left at the beginning and the end of production planning. In order to have a better understanding of the problem, we first define 7 characteristics of the dynamic programming as follows. The reversal equation is defined as follows, based on the optimal value of a state among all the actions taken in the transition of a stage. The procedure uses a backward method to solve the problem. We start from the last month, June, and we assume we are at the beginning of the month of June. At this point, we have the following. When we are at the beginning of June, since no boats should be left in the warehouse at the end of the planning, and since the demand for June is equal to 1, the status and action at the beginning of this month can only be equal to 0 and 1. In addition, when there is no boat left at the beginning of the month, since shortage is not permitted, we need to produce 1 boat. And when there is 1 boat left from the previous month, we do not need to produce any boat and pay only inventory cost. In May, since the demand is 2 boats, the situation at the beginning of this month can vary between 0 and a maximum of 3. Because when the inventory is 0, we can produce a maximum of 3 boats, which can meet the inventory for May and June. Also, the activity in this month can be a maximum of 3, in which case, when the situation is 0, the demand for May and June is fully met. In April, since the demand is equal to 3, production can change to a maximum of 4 boats, which not only satisfies the April demand, but also partially satisfies part of the demand for the month of May. Similarly, the boat inventory at the beginning of this month can change between 0 and the maximum warehouse capacity of 3 units. At the beginning of March, since the demand for this month is 5, the action cannot be less than 2 because the maximum warehouse capacity is 3. And by producing 2 boats and having 3 boats in the warehouse, we can meet the demand for this month. Similarly, when the maximum production can only be 4 boats, we cannot have less than 1 unit in the warehouse.